Let's look at networking fundamentals. Imagine you're playing a shooting game, say Call of Duty on Xbox. You're playing in London and the Call of Duty gaming server is in California. An enemy releases his bullet. It leaves his barrel and flies straight at your character. You're racing to get to cover in time. What you might not think about is the other race that is going on. While the in-game bullet makes its journey, the data that represents that bullet needs to make its own. It must travel from California to your Xbox in London in that same split second. It needs to travel 8,500 kilometers. First, it must traverse America before tunneling through underseas internet cables. These cables are the diameter of Coke cans and yet strong enough to withstand shark attacks and depths of up to 8,000 feet. It must make it to the UK, then to your internet service provider, to your home router, into your Switch, and finally to your Xbox, all in the blink of an eye. We've come across two key terms already, a switch and a router. Let's look at a simple home computer network to explore what these are. A computer network is simply a group of connected computers. This home network has two computers, a switch, and a router that's connected out to the internet. A switch connects devices on your local network. They connect computers, mobile phones, tablets, printers, etc., so that they can communicate with one another. Switches are responsible for physically getting the data where it needs to go on a local network. Later in the course, we'll discover the detail of exactly how this works. The router is your home network's gateway to the internet. It routes traffic from your computer to a destination on the internet. It also routes return traffic from the internet to the correct device on your home network. While it can tell traffic where to go on the home network, it relies on the switch to physically get it there. You might be thinking that in your home network you only have one device. Well, modern routers are often a switch, router, and wireless access point combined into one. Your computer will send outbound network packets to your switch. Your switch forwards the traffic onto your router, which routes traffic to your chosen destination on the internet. The inbound traffic hits your router, where it identifies which end device to send the packets to. It passes these packets to the switch, which physically passes it to the correct device. Let's look at how network packets might flow between two friends communicating over the internet that are both sat in their own home networks. They send packets from their computers, through their switches, and to the routers. The routers then find the best route through the internet to reach the destination router. Once they hit the router, these packets would be routed to the switch and then on to the destination computer. A home network, or a local group of connected computers, is called a local area network, or LAN. This home network connects to the internet, which is referred to as the Wide Area Network, or WAN. Wide area networks connect lots of local area networks together. The internet connects together LANs all over the world, allowing people to communicate from inside their own home networks. The WAN doesn't always have to be the internet. Companies can set up their own WANs, which connect lots of LANs together. Take the example of a business with offices throughout the country. Each office is its own LAN. The company could set up its own business WAN that connects all the local offices. This allows them to communicate securely without the use of the internet. With this lesson, we began to understand the layout of a basic network. This is referred to as the network topology. Mapping out a network is vital, whether defending, attacking, or responding to a cyber breach.